Okay, so the next question asks, what is a polar molecule? This is a good high school chemistry question. Basically, when you have a polar molecule, this is a molecule with an uneven share of electrons due to differences in electronegativity. So the key word I would say in this definition is that it is an uneven share of electrons due to differences in electronegativity. So let me have an example. I guess I should also add, though, that polar molecules also have a non-zero dipole moment. So this will make more sense when I write out an example of a polar molecule. So a non-zero dipole moment, and this just means that one end is slightly positive and the other end is slightly negative. Sorry, I can't spell right now. Slightly negative. Okay, so we'll write down one of the major examples of a polar molecule would just be the molecule of water. So what makes this polar molecule is that oxygen also has two lone pairs. If it didn't have any, then it would be a little less polar. But basically, since oxygen has a higher electronegativity than the two hydrogens, it has a slightly negative end. And on the hydrogen side of water, it has a slightly positive end. So this is an example of a polar molecule. And I'll also draw an example of what a non-polar molecule is. So a non-polar molecule would be something like methane. So as you can guess, a non-polar molecule is the opposite of a polar molecule. There's an equal share of electrons due to similar electronegativities. So let me just write this down. So this is non-polar. Since carbon and hydrogen, if you were to look up their electronegativity values, they have a similar electronegativity values. So what some people might get confused about is that there's a difference between having a polar molecule and having a molecule that has polar bonds. So for example, let me just box this little corner off. Let's say I had carbon and it had 4 chlorines on it. So as we all know, chlorine is much more electronegative than carbon. So I can draw all of the dipole moments. Well, I mean all of the arrows that signify that chlorine is more electronegative. So the carbon and chlorine bond is a polar bond because chlorine is more electronegative than carbon, but the entire CCl4 molecule is nonpolar. So this is because you'll see that they all cancel each other out. Chlorines cancel each other. Yeah. Yeah, so that's all there is to that. Let's see what the junior tutor said. A polar molecule is a molecule whose one end is slightly positive while the other is slightly negative. The absolute value of the difference in electronegativity of two bonded atoms provides an estimate of polarity. When the difference is very small or zero, the bond is covalent and nonpolar. When it is large, the bond is polar covalent or ionic. So I'm also going to add that this solution is correct. Oop. Sorry. Make this full screen. Hello. Okay. Anyways, this solution is correct. So they talk about that difference in electronegativity of two bonded atoms, but the second part of the definition just defines what a polar bond is. The first part is defining the polar molecule. So I'll just kind of clarify that. Okay, so I said that this solution is correct. However, a molecule can have polar bonds, but be a non-polar molecule overall if the dipole moments cancel each other out. And then I just gave my example. But this solution was still